a lot of people were waiting to see what you would do in your life after Tesla. It is Heron and Heron Power. What is the technology and what's the goal?
Yeah, Heron Power's goal is to build grid-scale power solutions to accelerate an all-electric future. The technology is basically leveraging the bleeding edge of power semiconductors to go directly from all the new energy technologies that are out there. They're all DC. This is solar, batteries, data centers, and they got to get to a grid which is AC, alternating current. And we're going to do that without transformers, fully with power electronics, high-frequency modular power electronics that we're designing here in California.
You were talking about the cutting edge of semiconductors in that field. We often, for example, talk about silicon carbide on this show.
Yeah.
But I wondered if you just give the backstory. Did you design this technology? Are you working with someone who did?
We're developing it in-house. We're taking the best-known topologies for advanced power electronics. There's a lot of great academic work, actually, in this space, and applying them to the grid-scale power electronics problem. Historically, the way it's been done is you have a low-voltage converter. Inverter rectifier has lots of different names, going from somewhere around 1,000 volts DC. That's what batteries are. That's what solar is. Data centers will be in the future. In fact, on this show, NVIDIA talked about 800-volt power electronics in their data centers.
He did, yeah.
And you'd go through a low-voltage inverter. So you'd end up with AC at 480 or 600 volts, and then you need one of these old-school, grain-oriented electric steel, oil-filled transformers to get up to 34,000 volts. And we're going to do it directly without the use of a transformer.
Drew, who is it you're disrupting here at the moment? Is it old-school electricity players? Is it the Schneider Electrics? Is it the Siemens? Who is it that you're really taking on here?
Yeah, I think we're trying to provide a more efficient, more compact, more scalable solution. And there's actually a lot of players in this space. You've got switchgear providers. You've got lots of different transformer providers. There's a lot of, honestly, like no-name power electronics providers and some bigger name players. And so it's a little bit of everyone, I would say. But really, when I zoom out, electricity growth is poised to triple over the next couple of decades. And that's not just due to AI, but also electrification of vehicles, buildings, everything else. And so there's going to be room for many players to support this growth.
Drew, give us that wider context, because we started off the show by talking about Meta looking and locking in nuclear energy for its future AI needs. How much of a bottleneck is energy? How much of a bottleneck is just the infrastructure that you're trying to rework? How much do we blame, well, incidents like the Spanish blackout on not modern enough infrastructure?
Yeah. The electricity sector is poised at an interesting inflection point. It's really the confluence of three major trends. First, you've got demand. For the first time in decades, there's actually robust electricity demand, and that's due to a number of factors. You've got electrification of buildings, transportation, you've got AI. You actually have a lot of new manufacturing load, which is exciting to see that coming to the United States and other developed countries. On the same time, you've got supply. In fact, abundant, clean, renewable energy is growing at explosively, to be honest. In 2024, over 500 gigawatts of utility-scale solar was deployed. That's over $500 billion of capital investment in solar that year alone, and that number was up 30% year over year. So massive increase in abundant potential supply. And then the last thing is aging infrastructure, especially in the developed economies. Over half of the infrastructure that's out there is over 30 years old. Some of it's 40, 50 years old.
That begs the question, Drew, sorry to interrupt. Who is your customer?
Yeah.
If you want to fix the entire grid, who are you selling to?
Initially, we're selling to energy project developers and data center developers.
Data center builders,
yes.
Like who?
Yeah, so actually we have letters of intent signed with Crusoe.
Interesting.
A leading AI data center developer and cloud services provider. And we also have a letter of intent signed with Intersect Power, one of the largest renewable energy developers.
You're working with Google.
In the U.S.
I think.
They are, yep.
I've got to ask you how you view Tesla's energy business, right, in the context of Heron. You're an alumni, but do you expect to work with Tesla on the kind of storage and solar side?
Certainly possible. We haven't had discussions, but
Right.
I look forward to having discussions in the future if it makes sense.
But the door wouldn't be closed for any reason.
Not that I could see. I mean, again, I think this is a huge problem. It's a massive sector, trillions of investment over the coming years. There's opportunity for everybody. But yeah, I think Tesla Energy has done an amazing job. I mean, obviously, I put a lot of my time in there over the past decade. If you go back to 2014, utility scale storage didn't exist. I mean, residential batteries didn't exist. And now in 2024, over 50 gigawatts of utility scale storage was deployed around the year, and invest CapEx of like $40 billion. That's massive. And that year itself, I think, was almost a doubling of deployments. So we're really at the beginning of the energy storage wave. And I expect Tesla Energy to continue to grow quickly.
You were the longest serving person at Tesla, basically behind Elon for a really long time. Would you just kindly share some insight in how it works at Tesla? You were one of sort of 3 stated executive officers. But the thing that I learned in my reporting is there's a really deep bench of talent, particularly on the energy side, at a time where everyone talks about Elon Musk looking elsewhere and being distracted.
Yeah, I mean, I'm super proud of what the Tesla team and myself and others were able to contribute to over the past 2 decades. Again, we talked about the energy business from 0 to nothing, but I mean 0 to something amazing. But I think we shouldn't overlook the contributions that Tesla provided to the EV space. Again, in 2014, maybe there was 100,000 total EVs, and last year 10 million, more than 10 million. I mean, that's 3 orders of magnitude. It's impressive. And continuing to grow. And Tesla didn't just do it itself, right? It encouraged many newcomers to enter the space. And I think that speaks to the capability of the team there. It's a really strong team, and I look forward to what they continue to do in the future. In fact, I just got a new Model Y, and I got to say, it's an incredible improvement over the Model Y I got in 2020 during the height of COVID.